Hello and welcome back to Dash School. I'm your teacher, Amanda B. Johnson, and as you will recall, we last left off talking about the digital ledger that is called a blockchain and how it is used to record changes of ownership among people. We ended with the questions: who gets to make updated entries into our e-money ledger? When do they get to make them? And why should anybody trust that the updates that they make are accurate? And all of those questions can really be summed up under one heading. Security. What is the security model of a blockchain? To understand that, we first need to conceptualize how a blockchain is run to begin with. And that is via a network, using the internet. The basis of the network is people keeping copies of the blockchain on their computers, and they are connected to one another via the internet. Irina in Russia communicates to Chen in China, communicates to Joe in Australia, communicates to Harry in Hawaii, communicates to Carrie in California, Marie in Mexico, Larry in London, and hundreds or thousands more people across the world, looking something like this. You get the general picture. And the purpose of this network is for all participants with a copy of the blockchain to agree on the state of that blockchain at any given time. For example, a situation like this in which Chen's copy of the blockchain reports that I have 3 e-monies, but Marie's copy reports that I have 47, would cause total chaos and would be of no use to anybody whatsoever. So the state in which all or the majority of the network agrees on the same versions of the blockchain is called consensus. And it is from consensus that a blockchain running network achieves most of its security. So, back to our example of Chen and Marie having conflicting copies of the blockchain. A big no-no, useless for everybody. How do we prevent that from happening and keep consensus about who owns what? I'm going to talk a little bit of computer science to you right now, but don't even worry, it's not a big deal. The mechanism used to maintain consensus on who owns what at any given time is called proof of work. And that just gives us a fancy way of deciding who gets to make an update to the ledger and when. See, the primary goal here is to not have both Chen and Marie broadcasting conflicting versions of our blockchain at the same time. We gotta have one or the other, so which is it gonna be? Chen's version or Marie's version? Using what's called proof of work mining, and I know it's weird that we would use the word mining, but you'll see why in a moment, we can maintain consensus. So back to a stripped down basic version of our network, right? What we don't want is 2 different people with copies of the ledger making an update at the same time. We want only one update to the ledger being made at a time, which everyone else can then take a moment to agree with and incorporate the update into their own copy of the blockchain. This is achieved using specialized computers called miners. Here's what one looks like. Yeah, they really are weird-looking, specialized computers. The computer code looking something like this, that makes our blockchain possible, contains a math problem to be solved. Seems kind of silly when I say it out loud, but I'm not kidding. The computer code has a self-adjusting math problem that these mining machines are built to solve. And the difficulty of the math problem is set to increase as the number of miners on our blockchain network increases. And all this fancy mumbo-jumbo is done to ensure one thing: that only one miner solves the math problem at a time, and that it happens consistently every few minutes. And what happens when a miner solves the math problem? Well, two things happen actually. First is that he gets a reward of newly created coins on the blockchain. Yes, I am not kidding. Newly created coins on the blockchain are paid to the miner who solved the math problem as a reward for proving his work. And secondly, he's the one who gets to create the next block. Or in other words, he's the one who gets to publish the next update to the ledger, containing all of the transactions that happened in the last few minutes. And thus does our blockchain, which is a chain of blocks, keep perfect record of every transaction that's made, the time that the block was published, and the total number of coins that exist, including the increase of coins, as the miners were paid in new coins as their reward. As an example, 1,000 coins, then 1,005, then 1,010, and on and on. In this way, our money supply, as recorded on the blockchain, can be considered open and honest. In other words, it's viewable to anybody. This also means that inflation, aka the new money created, is both transparent and predictable. Though currencies like Dash will not be inflated forever. But that's a topic for another day. What you need to know now is these accounts. They're not actually tied to your name. That wouldn't work at all. Accounts on a blockchain actually look something more like this. Long alphanumeric addresses, which are actually longer than these, are totally unique, and you can own as many of them as you like. What does this mean? What is this witchcraft? Well, it's based on a form of math called cryptography, actually, and you are totally smart enough to understand it. So hop on over to episode 3 to see how cryptography allows us all to have accounts on a blockchain. Cryptography is a form of mathematics that provides the basis for how different accounts on the blockchain interact with one another. So that whole public address, private key thing, the stuff that's mostly managed by your wallet, that's the cryptography bit. See, I told you it wasn't that hard.